Again, looking at chemical equilibrium, this is from 2012, our level paper. You can see that it was a half question in question 11. So this one's quite straightforward actually. Consider the following room temperature equilibrium reaction used to dissolve iodine I2 crystals in an aqueous solution of iodide ions I-. There's your iodine, there's your iodide ions, and you get these triiodide ions. So they tell us when 0.0800 moles of iodine crystals and 0.2400 moles of iodide ions were added to a deionized water made up to a liter solution. 0.0793 moles of triiodide ions were present at equilibrium. Write the equilibrium constant for 6 marks, the expression, the constant expression, and calculate the value of the equilibrium constant for this at room temperature for 12 marks. So very straightforward, 6 marks. We just need to write down the Kc expression, I3 minus all over I2 by I minus. And that's our 6 marks. And then for the calculation of the Kc, we need a table at the start, used / formed, and then at equilibrium. They've told us that it's a 1 liter flask, so we don't need to worry about dividing it by to get per liter, because it's already in a 1 liter flask. So the values that they've given us are 0.0800. Interesting to see all the decimal places as well. Just shows you how many decimal places they're looking for in the answer that you give back to them. There was none of this present at the start. Used / formed. Used is subtracted, formed is added. So we use the numbers in front of the species above. 1x, 1x, and 1x. They're a 1:1:1 ratio. And we're going to add them on here. 0 plus x is x. And this is going to be subtracted. 0.0800 minus x. And this is going to be 0.24 minus x. Just don't forget to put in those decimal places again at the end. So that is where we're at, and then the question tells us actually that there is this many moles at equilibrium. So they've told us what the x is, 0.0793. So we're going to subtract that from each of these values and we'll get, so 0.08 minus 0.0793, that will give us the value there, and 0.24 minus 0.0793 will give us the value there. So getting our calculator, 0.08 minus 0.0793, that gives us 0.0007 as the value there. And 0.24 minus the x value gives us 0.1607 as the value there for the iodide ions. And we know this value, 0.0793. Okay, we're calculating the value of this, so we're going to slot these values into that equation there. We're going to put this on top, 0.0793. We'll put it in its square brackets as well for completeness sake, and then we're going to put in 0.0007 and 0.1607, and we should get an answer for that. The value we get is 704.95, and that answers the value of the equilibrium constant Kc for that question 11b from 2012. The last part of the question says, state and explain the effect on the equilibrium concentration of triiodide ions of adding a substance that reacts with iodine, such as starch. Well, if you add something that reduces that reacts with iodine, I2, you're going to reduce the amount of this that's present. If you reduce the amount of iodine that's present, then you're going to move the equilibrium towards the left. And if you move the equilibrium towards the left, well, we're going to reduce the amount of triiodide ions. So if we're stating and explaining the effect of this on the concentration of triiodide ions, we'd say that the concentration of triiodide ions would decrease. That's stating it. And explaining it, it's because essentially it's because of Le Chatelier's principle, the stress applied and the system re-equilibrating to relieve the stress.